Hi everyone, my name is Kenzie Hull, and for my presentation I'll be focusing on the paper Nash Equilibrium in Strictly Competitive Games, Live Playing Soccer, written by Giancarlo Moschini. Here's the table of contents for what I'll be covering in this presentation. I'll begin with giving a background and description of the problem discussed in the research paper. I will then dive into how the author models this problem with the game model. From here, I will discuss the various findings in the research paper, how the author tested his framework, and then I'll review the overall conclusions. So if you recall back to lecture, we briefly studied soccer penalty kicks and how we can apply game theory to this mixed strategy. To refresh your memory, this scenario involves the shooter and the goalie, where the shooter must choose to shoot left or right, and the goalie must choose to dive left or right. Knowing this is a mixed strategy, we then applied a probability to each pure strategy to help us later determine the mixed strategy Nash equilibriums and payoffs. In this scenario, the pure strategies are for when the shooter shoots left or right and when the goalie dives left or right. Going more in depth, as can be identified in the matrix on the right, the kicker kicks to the left with probability p and kicks to the right with probability 1 minus p. Similarly, the goalie dives to the left with probability q and dives to the right with probability 1 minus q. Of course, we then analyze this scenario further to determine the equilibriums and payoffs, but this background is sufficient to introduce you to the topic that was discussed in my research paper. With that being said, Giancarlo Moschini recognized how this scenario is an essential stepping stone to analyzing soccer, but is not a scenario that is presented as frequently as when shots are taken dynamically in the play of the game. Thus, he decided to analyze a strategic setting in which shots on goal are taken dynamically from off-center positions in soccer matches. The image on the screen is a great example of this, where the forward on the red team beat the defenders and is taking a shot at goal from an off-center position. Although there are numerous different positions and distances in which the shooter can take a shot in a game, this scenario can be generalized to determine the best position for the goalie to stand, and based on where the goalie is standing, where the shooter should then aim their shot. When this situation is presented, it is often overall recommended for the goalie to defend the near post, or the post closest to the shooter, as it is often easier for the player to make a shot in the near post compared to the far post. Upon observing the goalie's positioning at the near post, this will then force the shooter to aim at the far post, which is generally a much difficult shot to make. As can be identified, denying the easier shot will hopefully increase the chances of the goalie making a save. This method for defending oncoming shots is frequently taught to young and professional soccer players all across the world. Knowing this presumed idea for how to play this one-on-one scenario, the author wanted to apply game theory to this mixed strategy to determine if this is indeed the most suitable way for the shooter and goalie to respond in this situation. With that being said, the author used the model outlined on the slide to conduct his analysis. As an initial framework, the author deemed the scenario to be a sequential zero-sum game. To elaborate on this, the author denoted how the goalie will first select his or her position P prior to the shot, and then the striker will choose his or her direction of the shot having observed P. These two actions are thus partook in sequentially, where the goalie makes the first decision and the player will make their decision based on the goalie's actions. After the shot has been made, it will either be accounted as a make or a miss. As can be identified in the visual, the striker will approach the goalie at some angle. When approaching the goalie, the player has two options: shoot the ball at the near post in or at the far post F. The probability of making a shot in the near post is given by Q, and the probability of making a shot at the far post is given by 1 minus Q. However, before the player makes their decision on where to shoot, the goalie must first choose a position P between the near and the far post. For the purposes of this visual, the goalie's position P is relative to the far post F. This is the exact model that was used in this research paper and the model that will be referred to throughout the remainder of this presentation. Further analyzing the scenario, the author recognized how the accuracy of the shot and its intended trajectory is all dependent on the shooter's skills and current position in which he or she takes the shot from. More specifically, how well the striker can aim, the angle of the striker relative to the goal, and the striker's distance from the goal makes the shot stochastic. Knowing this, the author chose to model this relationship with the following dependencies. When the player shoots a ball at the far post F, the shot will reach its intended trajectory with probability F in 0, 1, where 1 represents a made shot and 0 represents a missed shot. On the other hand, when the player shoots a ball at the near post in, the shot will follow its intended trajectory with probability n in 0 to 1. This is outlined in the first two bullet points on this slide. Now that we have some parameters set, the scenario can be modeled with the matrix on the right. As can be identified, we assume a save will always be made when the ball is shot at the same location as the goalie. For example, a save will be made when the player shoots a ball at the far post and the goalie is positioned at the far post. This is the same for when both are at the near post. On the other hand, from the cases where the player shoots a ball at the opposite post from where the goalie is standing, we must take into account the position and skills of the player to determine the accuracy and trajectory of the shot. The author chose to model this using the a sub f of lambda and a sub n of lambda functions, which are in their corresponding cells for opposite positionings of the goalie and shooter in the matrix. In the case where the goalie is positioned at the near post and the striker shoots a ball at the far post, the goalie will be scored with a probability of a sub f of lambda, where a sub f of lambda is within 0, 1. On the other hand, for the case where the goalie is positioned at the far post and the striker shoots the ball at the near post, the goal will be scored with probability a sub n of lambda, where a sub n of lambda is within 0, 1. Similar to the trajectory probabilities, 1 represents a shot is made and 0 represents a miss. The last bullet point on the screen outlines the parameters for lambda, which takes into consideration the location from where the shot originates. All these parameters combined take into consideration the specific skills of the striker and the location from where the shot originates to solve the accuracy function that determines the accuracy of the shot based off its origin. With that being said, any increase in the striker's skills or more optimal shooting position on the field will increase the overall accuracy for both the far post and near post shots. After outlining the model and its parameters, the author made a variety of conclusions. The first conclusion the author made was that it is indeed true that near post shots are more accurate than far post shots. This can be represented with the formula found on the first bullet point, a sub n of lambda is greater than a sub f of lambda for any lambda. Using the models and parameters outlined in the previous slides, the author then calculated two payoff functions for the shooter, which can be found on this slide. In these functions, n represents the near post, f represents the far post, p represents the position of the goalie, theta and lambda represent the skills and current position of the shooter, and k represents the goalie's reaction skills. Having these payoff functions, the author was able to conclude that there exists no pure strategy Nash equilibrium in the game, as the goalie's best response to the striker's choice of choosing the far post is p equals 0, and the goalie's best response to the striker's choice of shooting near post is p equals 1. In other words, the goalie should always be positioned in the far post when the shot is taken at the far post, and the goalie should always be positioned at the near post when the shot is taken at the near post. After concluding this, the author found that there does exist a Nash equilibrium where the striker mixes between the near and the far posts. The pair of strategies P star and Q star that constitutes the Nash equilibrium of the game can be found here, where they were verified to be unique and sub-game perfect. All the parameters in these equations are the same as those described previously. Under the assumption of the first conclusion that the near post shot is easier than the far post shot, the author made a second conclusion that the striker will favor the far post and the goalie will favor the near post. Because the striker will have a higher accuracy of making the shot at the near post in equilibrium, the goalie will want to cover the near post more to prevent an easy goal. Having seen the goalie defend the near post, the striker will then be forced to favor the far post and aim their shots there. Using the pair of strategies P star and Q star that constitute the Nash equilibrium, we can represent the actions of the goalie and the striker by making Q star less than 1/2 and P star greater than 1/2. This signifies that the fraction of goals scored at the near post is expected to be less than half, while the fraction of goals scored at the far post is expected to be greater than half. The reason the author chose to make the equilibrium strategies P star and Q star independent of the skill parameters of the striker and goalie is so that this framework could be expanded as a reliable rule for soccer players of all different skill levels. To reiterate the author's previous conclusions, it is expected that after observing numerous real-life soccer examples in Nash equilibrium, one should observe more goals scored at the far post than at the near post. To test the Nash equilibrium and parameterization that the author developed, the author chose to analyze and classify all goals scored in the Italian Serie A in the season 2002 to 2003. Another testing option would have been to record all shots taken on goal in a variety of games determine whether the striker had the choice between near and far posts, determine where the striker aimed, and then note whether or not the goal was scored. However, the angles in which these goals are shot on television programs and the amount of time this would have consumed was deemed insufficient and inefficient for the analysis of this project. Thus, the author chose to focus on only goals scored in the Italian Serie A in the season 2002 to 2003, as these goals were recorded from a variety of different angles since they were broadcasted from numerous different television programs. Italian Serie A is one of the top professional soccer leagues in the world, and during the 2002 to 2003 season, there were a total of 18 teams, where each team played each other team twice. In total, the season involved 304 matches, where all goals scored were observed by the author in television broadcasts and were classified according to the mode of scoring. In all, 783 goals were scored throughout the season, with an average of 2.58 goals per match. Each of these goals were allocated into one of 7 categories based on the mode of scoring: an own goal, penalty kick, free kick, header, near post, far post, and other. After categorizing all the goals, the author deemed that only 195 of these goals scored were in a situation where the striker had a meaningful choice of shot direction, and were thus the only goals that should be analyzed to test his model. Knowing that 65 of the goals analyzed were scored in the near post, and 131 of the goals analyzed were scored in the far post, it can be identified that about 1/3 of the goals were scored at the near post and 2/3 of the goals were scored at the far post. Recalling the author's prediction that in Nash equilibrium, the fraction of goals scored at the near post would be less than half, or Q star is less than 1/2, we can conclude that this testing supported and proved the author's hypothesis, as the fraction of goals scored in the near post was about 1/3, which is indeed less than 1/2. Overall, the author's testing and analysis can be organized into 3 main findings. Knowing that near post shots are more accurate than far post shots, a goalie will typically favor the near post while the striker favors a far post shot. From here, of which was proved via the goals scored in the Italian Serie A season, in Nash equilibrium, one should observe more goals scored at the far post than at the near post. It can thus be concluded that the current teaching framework for having the goalie mark the near post when presented with a shot by a player is indeed plausible, as it takes away the easy shot and forces the player to aim for the far post. These are my citations. Thank you very much.